Hello guys, and welcome in this new recording. My name is Emmanuel, and on this channel I talk about my C++ and Python experiment. So today we continue with a follow-up of the atmosphere implementation which we mentioned in the previous video. If you remember, last time I said that there was still a small issue with the display because we could get this kind of weird shape depending on the orientation of the camera. And the good news is I have now fixed this issue. It was a pretty tricky issue actually. It took me the complete day, but it was definitely worth it. I learned a few things in the process. So let's see together what were the necessary steps to fix this problem. In fact, at the end of the previous recording, I had mentioned already that I wanted to try implementing the logarithmic depth buffer. So this is the first thing that I have implemented here. First thing I checked concerning this logarithmic depth buffer were those 3 pages from the Otera blog. So this were in fact the most relevant resources I could find concerning a modern implementation of the logarithmic depth buffer. And if you read those documents carefully, so this is the first one, and in there you have a link here for another one, which is this page. And there was another one mentioned at the end of this document here, maximizing depth buffer range and precision, which is this page here. The 3 pages are basically talking about the same formulas and small variation around this. And at the end, I think that this was the last one. The formula seems to be something like that. So what you need to understand at the end is that this is basically the only real formula that you need. But for my part, in fact, I was rather considering using directly this one, which is the same thing with some simplification and some changes. So I'm using rather this version here, except that I'm going to use log2 instead of log. I'm going to keep this C factor, and actually in my code I've set that to 0.01 so far. And yeah, this is it. Why do we use this one? Because in WebGPU the depth range is 0 to 1, not -1 to 1. So with this in mind, I then updated the uniform data structure for the camera, adding this C log factor and the F log coefficient. Then when it's time to update the camera buffer, we're going to perform as usual, and at the end we're also going to update this F log coefficient using the log2 function, as I said, and also taking into account the C log factor. And on the WGSL side, I actually just added those 3 functions. I'm going to use this one to modify a position specified in the clipping space. So we assume that when you receive this clipping space position value, the W component is actually the current depth from the camera point of view. So then you use this depth value to compute the logarithmic Z value using this function here. And that's where we find the formula mentioned in the Altera block. And finally, we have this function here, which is going to do the opposite. It's going to take a depth value in log scale and convert this back into the corresponding linear depth. Next, I simply updated the shader that was generating the planet display. So instead of just setting the output position to this value, I'm now using this output position as an input to the clip2 log z function, and this would apply the logarithmic scale in the depth. And finally, on the render atmosphere side, this was the old code I was using, but we're not using that anymore. And now we're just going to retrieve the depth value from the texture here, and we just apply the log z to linear depth function. And with this log depth buffer change, we move from this kind of display here to this kind of output. So as you can see, we don't have any kind of z fighting anymore. But unfortunately, it's not really solving the main issue that we have, which is this strange light circle display with well, blurry display otherwise, and the changing shape that we see here when we get close to the horizon of the Earth. So yeah, at that point, I had to investigate further because the logarithmic depth buffer was not resolving the issue, the main issue that I had. So I did a lot of different experiments. For instance, here I was trying to measure the actual altitude of the point on the Earth, and as you can see, the altitude value was changing depending on where the camera was in space, so it really didn't really make sense at all. But then another experiment that I did was this one, where I was trying to display a color map using just the raw depth value from 0 to 1, and when you display that, you actually see that it seems consistent. The color are changing depending on the distance to the camera, so this was the expected behavior. Pushing it a bit further, I wasn't trying to apply the color map to the linear depth, so I was using the logarithmic depth and converting this back to linear depth, and you could see again that the display seemed consistent. You had the color changing really depending on where the point was compared to the camera itself, so not this kind of weird circular display that we've seen before. So again, this seemed okay. So everything was really indicating that this computation for the point where we have an intersection with the Earth was wrong somehow. But when I was checking what we had for the distance to intersection, it seemed correct. I then also considered maybe it was how I was computing the view direction, which was incorrect. I tried to somehow recompute that manually, providing the view angles and aspect ratio, and again I reproduce exactly the same incorrect display. So currently I'm still not quite sure what this issue is. It seems it could be some kind of floating point precision limitation, but this also seems really strange to me. But anyway, the solution that I found for now is to update the planet shader here to also keep track of what is the current altitude of the different vertices that we are outputting. Then this altitude value, we're going to output that as part of the resulting vector, which means that we cannot use the RGB channel anymore to output the color that we want. So what we're doing instead is we're going to pack the RGB values in a single channel here. And this value is going to become the first channel. And of course, for this to work, I had to update the color texture using the render pass to be an RGBA FLOP32 format. And then when it's time to render the atmosphere itself, I'm going to retrieve this information from the color texture, and we're going to unpack the RGB values from the first channel here. And then we use the second channel to retrieve the altitude that we want for the current point. Next, what we do is we're going to take the previously computed point and just renormalize that and use the altitude that we want above the Earth radius itself. And with that solution, we don't have this weird display anymore. It's still pretty expensive if you think about it, because we had to switch to an RGBA FLOP32 format for the output texture. The point is, we could maybe just use 2 channels instead of 4, so we could use RG FLOP32, but still it's maybe not an ideal solution, because now we basically use only 1 channel to produce the color, and it would be pretty tricky to apply blending, for instance, anymore if you were to display other objects on top of the planet itself in the same rendering pass before applying the atmosphere effect. So in the long run, maybe a better option would be to use 2 render targets and render the color normally in the first target, the color 0 target, and render the altitude value in a secondary target. But yes, after spending the complete day working on that and not making any kind of progress, I was pretty happy to at least find something that was starting to work and pointing me in in a working direction. So yeah, this is it for the moment. I will keep working on that anyway, and we'll see how this goes. So if you have any question, don't hesitate to let me know in the comments, and if you like this kind of content, don't forget to subscribe to the channel. And this is it for this time, guys, so see you next time. Bye bye.